Welcome back. Today we're going to be talking about implicit differentiation, and I'm going to go over 5 multiple choice and 3 free response. The first question says, if x squared plus y squared is 25, what is dy over dx? So what we want to do here is I'm going to start by differentiating both sides of the equation with respect to x. So d over dx for x squared plus y squared equals d over dx of 25. Okay, and then I'm going to simplify that. I'm going to say, well, that means that we're going to have to take the derivative with respect to x of x squared and also the derivative with respect to x of y squared, and then the derivative with respect to x of 25. And then we'll evaluate each of those. So starting with what is the derivative of x squared with respect to x? Well, for that, we just use the power rule and say that's going to be 2x. Then for the next one here, what is the derivative of derivative of y squared with respect to x? Well, that would be 2y times dy over dx. And then for the third one, we would have the derivative with respect to x of 25. That is just going to be 0, because what is the derivative of a constant? It's just 0. All right, and now I'm going to rearrange this in order to solve for dy over dx, because that's our entire goal here, is to find out what that would be. So we're going to end up with 2y times dy over dx is equal to negative 2x. Then if I divide both sides by 2y, I get that dy over dx is equal to negative 2x over 2y. The 2's can cancel, and we'll get negative x over y, which is a. So that would be the first response there. All right, so let's try a second one. For the curve defined by y cubed plus xy equals to 6, what is the slope of the tangent line at 1, 2? Okay, so first thing we need to do is we need to differentiate both sides with respect to x is our first step here. So let's do that. So we need to take the derivative with respect to x of y cubed plus the derivative with respect to x, xy, equaling the derivative with respect to x of 6. Okay, then we're actually going to take those derivatives. So for the first one, we're going to get 3y squared by using the power rule. And then we're also going to get dy over dx. Then for the second part here, we have the derivative with respect to x of x times y. So starting with, we have to use the product rule, combination with the chain rule here in order to figure this out. And so what's this one going to be? Well, first we're going to just have y, right? If we consider that, if we consider y at first as though it's just a constant and x is the variable, we would just get y in that scenario. And then what if we have the scenario where we have x and y, but we're taking the derivative with respect to y? Well, if that's the case, we're going to get x. And because we're doing that, we have to also do dy over dx, right? And actually, I want to explain a little bit in a bit more detail why we are putting dy over dx, right? Because originally, we're taking the derivative with respect to x, right? That's what we're doing. But if we have d over dx times dx over dy, right? Then if we're doing that, then these would cancel and we get d over dy, derivative with respect to y. But in order to do that, right, in order to cancel those out, we must put dy over dx, right? Because this would cancel out with this one, right? So notice those two are going to cancel out with each other, and then we still have this one here, right? And so we are able to multiply these two things that would cancel, right? We're allowed to use these two that would cancel here. And from there we can say, okay, great. Well, then we're going to be taking the derivative with respect to y, and then we have to multiply by we have to, well, I keep saying multiply. It's not exactly multiplying, but we have to apply dy over dx here as well, because then if we don't, then we're essentially just multiplying by this, but not putting anything to counteract that, right? We're adding things that aren't reciprocals, and we're not able to do that, right? And so that's why we keep seeing dy over dx everywhere, right? Notation wise, at least that's why that's the case. Okay, and then we're going to have that's equal to d over dx of 6. So the derivative with respect to x of 6, well, that's a constant, so that's just going to be 0. Okay, very good. Next, we're going to simplify a little bit. So I'm going to put all the terms that are of dy over dx together. So that's going to be 3y squared plus x. And then y is separate from that, plus y is equal to 0. Then I'm going to try to isolate here. So I'm going to subtract y from both sides. So we'll get dy over dx is equal to 3y, or sorry, not yet, is equal to negative y. And then I'm going to divide by 3y squared plus x. So we'll get dy over dx equals negative y over 3y squared plus x. And then I'm going to plug in my values. It said to plug in 1 for x and 2 for y. So therefore, that's going to be negative 2 over 3 times 2 squared plus 1, which is equal to negative 2 over 13. And that is going to be d. And so d, negative 2 over 13, would be our result there. And there we go. All right, let's try a third example, this time with trig. So here they would like us once again to find dy over dx. So first thing we're going to do is implicitly differentiate. We'll differentiate both sides with respect to x. So let's do that. Like that. All right, so now if we do that, what are we going to get? The derivative of sine xy, well, the thing is, derivative of sine in general would be cosine, so we're going to get cosine x times y, and then we also have to apply the chain rule here. So what's the derivative with respect to x of what's in there, which is x times y? We'll get to that in the next step. And then that's going to be equal to the derivative with respect to x of x. And what's derivative of x with respect to x? Just 1. So we'll just put 1. Okay, then let's take the derivative with respect to x of x times y. So for that, we're going to end up with, for the first part, y, right? If we assume that y is just a coefficient and x is x is the variable here, and then plus, if we want to differentiate with respect to y as well, we get x dy over dx equals to 1. And now we just have to solve for dy over dx. So what we're going to do now is we're going to start with dividing both sides by cosine of xy. So we're going to get y plus x dy over dx is equal to 1 over cosine xy. Then we're going to subtract, or actually, you know what? There's a better way to do this. We can distribute this into both of these first, actually. So let's do that. That's probably a little bit better. Okay, so then we're going to get y cos xy plus dy over dx of x cos xy equals to 1. Okay, so next I'm going to subtract y cos xy from both sides to get that dy over dx is equal to 1 minus y cos xy, and then we'll divide by x cos xy, and then that is going to be exactly like answer A, and so answer A is going to be my final result there. All right, so this one says the equation e to the power of xy is equal to y implicitly defines y as a function of x. what is dy over dx at 0, comma 1? All right, so the first thing I'm going to do is I'm going to differentiate both sides with respect to x as always. So d over dx, x e to the power xy is equal to d over dx of y. Okay, so using the chain rule on the left, what is the derivative of e to the power of xy with respect to x? Well, of course, the first part is just repeat e to the power xy. There we go. And then we also have to take the derivative of x times y with respect to x, because we have to use the chain rule here. So that's going to give us y plus x dy over dx. And then what is the derivative of y with respect to x? Well, that will just be dy over dx. Okay, and then we need to solve for dy over dx, right, is our entire goal here. So first thing I'm going to do is I'm going to just use the distributive property. So we're going to end up with e to the power of xy times y plus dy over dx of x e to the power of xy is equal to dy over dx, like that. And then I probably want everything with dy dx to be on the same side and everything without to not be on the same side. Okay, so let's fix that. Let's have e to the power of xy times y stay over here, and we'll put that as equal to dy over dx minus xe to the xy dy dx, like that. All right, and then I'm going to factor out the dy over dx. So if we do that, we're going to get dy over dx at the end here. And then in here, we're just going to have 1 minus x times e to the power xy, like that, is equal to the other stuff. And then I'm going to divide. So we're going to get dy over dx is equal to e to the power of xy times y over 1 minus x e to the power of xy, like that. And then we need to substitute in our values of 0 and 1 now that we have it. So 0 for x and y, 1 for y. So then we're going to end up with e to the power of 0 times 1 over 1 minus 0 times e to the power of 0. So then we're going to have, well, e to the power 0, that's just 1. 1 times 1, also just 1. So I'm going to put 1 there. And then how about over here, we have 1 minus 0 times e to the power 0. Well, 0 times anything is just 0. So it's just going to be 1 minus 0, which is also 1. So the final answer is 1. And so that's what I'm going to select here. Answer C is 1. All right, we're going to do one last multiple choice. This one is going to be kind of a higher order derivative. This one here, they're asking for the second derivative of y with respect to x. So let's talk about how we would find that as well. So first step for this will be just the same as before. We're going to differentiate everything with respect to x, right? Because in order to get the second derivative, we first have to find the first one. So let's do that. Let's differentiate everything with respect to x. Like that. Okay, so what is the derivative of x cubed with respect to x? That's going to be 3x squared. What's the derivative of y cubed with respect to x? That's going to be 3y squared times dy over dx. And then that's going to be equal to the derivative of 9xy with respect to x. Okay, so that's going to be 9y plus 9x dy over dx. And so there we go. All right, so next thing I'm going to do is we're going to solve for dy over dx. I know that's not the final thing we want, but we do have to find the derivative of y with respect to x in order to even have any chance of finding the second derivative of it. So I'm going to move everything with dy over dx to the left and everything without to the right. So if I do that, I'm going to get that 3y squared minus 9x dy dx is equal to 9y minus 3x squared. That means dy over dx is equal to 9y minus 3x squared over 3y squared minus 9x. And so there we go. Okay, next thing I'm going to do is we're going to differentiate again and get the second derivative. And I'm going to do that using the quotient rule. So let's do that using the quotient rule here. So the quotient rule states, so first we have to do derivative of the top. So what's derivative of the top? So what's derivative of 9y minus 3x squared? Well, that's going to be 9 dy over dx minus 6x. So that's derivative of the top. And then times the bottom, right? So bottom, we're just going to copy it. And then minus derivative of the bottom times the top. So what's derivative of the bottom? Well, that'd be 6y dy dx minus 9, and then times the top, which was 9y minus 3x squared. And then that's all over the bottom squared, right? Like that. Okay, now we're going to plug in our values, which actually I forget what they were. What were they? They were 2 and 4. So I'm going to plug in x is equal to 2 and y is equal to 4. And we also need to know what dy over dx is with respect to that as well. So we're also going to need to be able to plug in dy over dx. And so to get that, I'm actually just going to plug in 2 and 4 back into the dy over dx that we found. So that's going to be 9 times 4 minus 3 times 2 squared over 3 times 4 squared plus 9 times 2, which let's see what that's going to be equal to. Looks like that's going to be 36 minus 12 over 48 minus 18, which that's going to be 24 over 30, which is, I believe, just 4 over 5. Yeah, by dividing both by 6. Excellent. So this would just be 4 over 5 then. Okay, so now I'm going to plug in all those values and figure it out. So we're going to have 9 times 4 over 5 minus 6 times 2 times 3 times 4 squared minus 9 times 2 minus, let's see, 6 times y. So 6 times 4 times 4 fifths. Actually, let's scroll down here so you guys can see all that. Minus 9 times 9y, which y was 4, minus 3 times 2 squared. All right, and then all over 3 times 4 squared minus 9 times 2, all squared. All right, and then I'm just going to calculate that and see what that ends up giving us. I'm actually just going to kind of cut to the chase on this part. We're going to end up with, in the numerator, negative 1,944 over 5, and then in the denominator, 900. And then if we just do the division on that, we're going to get negative 5 over 8. So I know we're just kind of cutting to the chase on some of that ending stuff because I'm sure we know how to plug in numbers. We know how to, do all that kind of stuff. So we end up with 5 over 8 or negative 5 over 8 as our answer. And that would be answer D. So that's the answer for that one. All right, in a separate video, we will do the long answer questions because this video is already kind of getting a little bit long, but there will be another implicit differentiation video with 3 free response questions.